Hi learners! Welcome to Math is Fun with Sir O. Today, I will be discussing the language of functions. And so, we're going to learn relations and functions. Before we go to our discussion, I'm going to read first our learning outcomes. First, we're going to discuss the definitions of relations and functions. Second, determine the domain and range of the relation. Third, know how to map the domain to range. Fourth, familiarize the different types of relations. And last, know how to determine if the expression is a function or relation. Would there be any question with our learning outcomes? None. So before we go to our lesson proper, I have here a short activity. So this is a family tree. By the way, were you able to make your family tree when you were in high school or elementary? Yes, of course. Right? So we have here a puzzle. I'm going to read our problem. So Jack said to Chris, "You are my father." Chris said to Janisha, "You are my mother." Janisha said to Manny, "You are my son." What is the relationship between Jack and Manny? I will give you 30 seconds to answer this question. Or if you want more time, you can pause this video. Alright, so now let's go back to our question. So what is the relationship between Jack and Manny? Very good. So the answer would be uncle and nephew. Manny is the uncle of Jack, and Jack is the nephew of Manny. All right? So you know also your family tree. And what is a family tree? A family tree is also called a genealogy or a pedigree chart. So it means that a family tree is a chart representing family relationships in a conventional tree structure. All right. So it says there relationships. So we're talking about relation, and that would be our topic for today. What exactly are relations? A relation pertains to the relationship between two or more variables. For example, we have the relationship between salary and number of hours of an employee. So meaning the amount of salary is determined in the number of hours the employee rendered his job in the company. Another example would be the mother and children relationship. And we have also height and weight of a child relationship. All right. Any question for relationship? None. So of course, you have only to think that a relationship has two or more variables. They are related to each other. In mathematics, relations are set of ordered pairs. So we have your x and y values. So the first coordinates represented by our x come from a set called the domain. So they are independent variables, and we think of this as our inputs. Second coordinates, which is your y, are thought as outputs and come from a set called our range. They are dependent variables. So for example, we have our set 1, 7, 2, 11, 3, 6, 4, 8, and 5, 32. It says there that our domain are our x's. So it follows we have 1, 2, 3, 4, 5. So these are our domain. Okay. So our x values. And our range is 6, 7, 11, 8, 32. So they are our y values. All right. Any question? Relationship as a subset. So we have here an example. So let's A is equal to -1, 0, and B is equal to 1, 2, 3. We're going to define a relationship R from A to B as follows. So for our given, it should be any XY elements of our A cross B. Can you still recall your Cartesian product? So we are going to apply our Cartesian product in this lesson. So our xy element of R means that we have to perform these formulas. So that is the sum of your x plus y divided by 2. If the answer is an integer, then we can say that it is a relation. So now we have here three guiding questions to answer this problem. So number one, we're going to state explicitly which ordered pairs are in A cross B and which are in R. So meaning we're going to identify the elements of our A cross B as elements of our R. So number two is negative 1 R1. All right, so meaning we're going to perform this formula. So that would be x plus y divided by 2. Okay. Then we have your is 0 R2 and is 0 R3. Okay. Now for our third guiding question, what are the domain and range of R? Now let's go to our solution. For number one, state explicitly which ordered pairs are in A cross B and which are in R. So let's recall our given. So A is equal to negative 1, 0, and B is equal to 1, 2, 3. And we're going to perform this formula, x plus y all over 2, element of R. And so for our A cross B, so that would be equal to negative 1, 1, negative 1, 2, negative 1, 3, 0, 1, 0, 2, and 0, 3. So we're going to verify each of these elements using this formula, and if the answer we obtained is an integer, therefore it is an element of our R. So let's start with our negative 1, 1. So plugging in our values of negative 1, 1 to the formula, that would be equal to negative 1 plus 1 all over 2. And the answer is equal to 0 over 2. And it is equal to 0. Right? Since 0 is an integer, then this is an element of R. All right? So now let's go to the next element, which is negative 1, 2. So plugging in the values, we have negative 1 plus 2 all over 2. And the answer is 1/2. Since it is a fraction and not an integer, therefore it is not an element of R. Okay, so we place there an X. Now let's go to the third element, negative 1, 3. So again, plugging in our values, we have negative 1 plus 3 all over 2. And the answer is 2 over 2, and that is equal to 1. And 1 is an integer, right? And so it is an element of R. Okay, so now let's go to the fourth element, 0, 1. So again, plugging in the values, that is 0 plus 1 all over 2, and that is equal to 1/2. Since 1/2 is a fraction, therefore it is not an element of R. Now let's go to the fifth element, 0, 2. So plugging in the values, that would be 0 plus 2 all over 2, it gives us an answer which is 2 over 2, and that is equal to 1. So since it is an integer, therefore it is an element of R. And we have our last element, 0, 3. Okay, so plug in our values, that would be 0 plus 3 all over 2, and it gives us 3/2, and it is a fraction. So therefore, it is not an element of R. So therefore, the elements of R are negative 1, 1, negative 1, 3, and 0, 2 only. Any question? None. All right. So now let's proceed to our number 2. Is negative 1 R1? All right. So again, we're going to use the same formula. X plus y all over 2. So that would be negative 1 plus 1 all over 2. So the answer would be 0 over 2, and that is equal to 0. And since 0 is an integer, the answer would be yes, because negative 1, 1 is an element of R. All right? How about is 0 R2? So again, we have 0 plus 2 all over 2, and that gives us 2 over 2. Then it is equal to 1. And it is yes, because 0, 2 is still an element of R. How about 0, 3. So that would be 0 plus 3 all over 2 is equal to 3 halves. Since it is a fraction, it is a no because 0, 3 is not an element of R. All right? Clear? Number 3, what are the domain and range of our R? So let's recall our givens. So A is equal to -1, 0, and B is equal to 1, 2, 3. And then we're going to recall again our Cartesian product, and that would be A cross B is equal to -1, 1, -1, 2, -1, 3, 0, 1, 0, 2, and 0, 3. So for our domain, we're going to list all our x's, and that would be -1, 0. And for our range, we're going to list all the values of our y, and that would be 1, 2, 3. Now, what did you observe with our domain and range? Very good. So our domain corresponds to the elements of our A, and our range corresponds to the elements of our B. All right? Okay. Now, what are the types of relations? So we have actually 3 types. Number 1, one-to-one relation. Number 2, one-to-many relation. And number 3, many-to-one relation. So let's start with one-to-one relation. Suppose we have this representation of our relation. So we have here set of the names of the girls. And here we have set of the names of the boys. First, let's have Leia. So Leia is mapped to Sunny, meaning Leia is related to Sunny, or Leia corresponds to Sunny, or Leia is associated to Sunny. Same also with Mary. Mary is mapped to John. So Mary is related to John. Becky is mapped to Peter. So it follows that Becky is related to Peter. So that's how you show your one-to-one relationship. Meaning, for every name of our set of the girls, it corresponds to one name of our set of the boys. All right? Any question? So the best example for this in real-life situation is the relationship of the married couple. So you have your husband and wife. All right? Also, if you have your boyfriend, also girlfriend, right? So one-to-one relation. Number 2, one-to-many relation. So as you can see here that Leia is related to both Sunny and John, meaning there is one element in the set of the girls that is associated or related or corresponds to 2 names in the set of the boys. So the best example for this in real life situation would be the relationship of a mother to her children. Okay, so we have one mother and she is related to her children. All right? Any question? None. Now we have another one. Number 3, many-to-one relation. So this time, we have 2 elements in the set of the girls that are associated to one element in the set of the boys. So we have here Leia and Mary, which are related to Sunny. All right? So the best example for this in real life situation would be the relationship of the children or the siblings, right, to their parent. Maybe a mother or a father. So children to mother or children to father. Okay? Any question for our 3 types of relations? None. So again, if we're going to recall, we have your one-to-one relation. Next, we have one-to-many relation. And lastly, many-to-one relation. Okay? So what are functions? So we're done already with relation. So this time, let's define function. A function is a relation between a dependent and independent variable or variables where for every value of the independent variable, x or input, there exists a unique or a single value of the dependent variable, y or our output. So let's think our functions as a machine. So we have here a representation. So this is our machine. So of course, if we have our machine, we're going to have our inputs. So we're going to put something here in our input, then the function will process it, then eventually it will have its output. Now, if we're going to relate that in mathematics, our function machine serves as our rule. So if we have our input, then our rule will process our input and eventually it will give an output. For example, if we're going to represent our input with x and our rule says that we're going to add 4 to our input, then our output will be the sum of our x and 4. So for example, if the value of our x there is equal to 3, then our rule says we're going to add 4 to our 3, and thus our output there is equal to 7, right? Okay, so this time we're going to know what is the rule or function in our example. So for our input, these are the list of independent variables. So we have 2, 3, 4, and 5. And here we have our corresponding output or dependent variable. So we have, if we're going to input 2, the answer is 4. If we're going to input 3, the answer is 9. For 4, the answer is 16. And for 5, the answer would be 25. Now, what would be our function? So let's establish a rule. So we're going to have a pattern out of this. So now we're going to copy our unknown. So that would be f of x is equal to unknown. Say, for example, we're going to use the first independent variable 2, right? And I said earlier that the output would be the dependent variable, which is 4, that correspond to our 2. So that would be f of 2 is equal to 4. But then 4 can be rewritten as 2 squared. So we have f of 2 is equal to 2 squared. Next, we have your x, which is equal to 3. So f of 3 is equal to 9. So 9 can be rewritten as 3 halves. So therefore, we have f of 3 is equal to 3 halves. Let's go to x is equal to 4. So f of 4 is equal to 16. But 16 can be rewritten as 4 squared. And so f of 4 is equal to 4 squared. And lastly, we have 5. So f of 5 is equal to 25. But 25 can be rewritten as 5 squared. So therefore, f of 5 is equal to 5 squared. Now, what is the pattern that is going on in our mathematical sentence? Very good. So meaning, we are squaring the input. So that would be f of x is equal to the square of our input. So it is f of x is equal to x squared. Any question? None. All right. So now let's go to the comparison of functions and relations. So if going to represent this using the Venn diagram, so the functions is just a subset of our relations. So what can you say about the functions? Yes, so the functions is just a part of our relations. Thus, we have this very important statement. All functions are relations, right? As you can see in our Venn diagram, that functions, because it is only a part of relations, thus it is said there that all functions are relations, but not all relations are functions, okay? Not all relations are considered functions. So again, all functions are relations, but not all relations are functions. So you have to memorize or familiarize this statement, okay? So if you forget this statement, just think of this Venn diagram, that our function is just a part of our relation. So if that's so, we think which types of relations are functions? Is it one-to-one relation, one-to-many relation, or many-to-one relation? So let's verify. So we're going to define again our function. And function is defined as for every value of the independent variable, there exists a unique or single value of the dependent variable. In other words, For every x that we have, there exists a unique or single value of y. We start with one-to-one relation. Do you think it is a function or just a relation? So we have Leah is mapped to Sunny, Mary is mapped to John, Becky is mapped to Peter. So, is our example of representation satisfies the definition of a function? That for every x, there exists a single value or unique value in y. Yes, you are right. Therefore, one-to-one relation is a function, right? So you think of this. So let's say, for example, if we're going to take a test. So it follows that you will have one definite score. So meaning, for one student, that student should have only one score. All right? Any question? None. Okay, how about number two? One-to-many relation. Is this a function or a relation? Okay, so we have there, Leah is mapped to Sunny and as well to John. Does our representation satisfy the definition of a function? So for every element of x, there exists one or single value of y. No, that is right. It is not a function. So you think of this. So you have taken a test, right? Is it possible for you to get two scores? Like, for example, you will get a perfect score or another score which is 50 out of 100. So is it possible for you to have two scores? Definitely not, right? So therefore, one-to-many relation is not a function. Now let's go to the third one. Many-to-one relation. Is this a function? So let's see. So Leah or Mary is mapped to Sun. So Leah is mapped to Sunny or Mary is mapped to Sunny. So for every element of x, there exists one single element of y. What do you think? Correct. So this is also a function, right? So you think of this example. So for example, you and your classmates were able to study very, very hard. Is it possible for you, all of you, to get the same score? Like, for example, the perfect score is 100. You are 40 in the class. Is it possible for all the 40 students to get the same score, which is 100? Yes, definitely. And that is an example of many-to-one relation that is said as a function. All right. Any questions so far? None. So we have different ways of representing functions and relations. Number one, by means of ordered pair. So we have your x, y values. Second, you can also use equation. So that would be y is equal to f of x. And then we have your table. You can also do mapping and by means of a graph. So we have here a short activity. So we're going to express y is equal to x plus 1 in various forms. So meaning we're going to use the 5 ways of representing our functions and relations. And we're going to determine as well if it is a function or not a function. So for our solution, we're going to let our x equals to -2, -1, 0, 1, and 2. So meaning we're going to supply the values of our x. First, let's have a table. In this table, we have here our x values. And we're going to use our equation, which is y is equal to x plus 1 as our rule. And then we're going to have here the y values. So for -2, we're going to replace our x there with -2, and that would be -2 plus 1. -2 plus 1 is equal to -1. And that is the y that corresponds to the value of x, which is -2. For -1, we have to replace x with -1, and that is -1 plus 1. It gives us 0. And 0 is a number that corresponds to the value of -1, right? And so we have your 0 corresponds to 1, 1 corresponds to 2, and 2 corresponds to 3, right? So you can show your solution by means of a table. So this is a good representation to show our functions and relations. Now, can we say that this is a function or not a function? Definitely it is a function because for every x value, we have one y value. Okay. This time, we're going to map. All right. So we're going to take all the values of our x from the previous slide. And of course, we're going to map them to their corresponding value in our y. All right. So we have here -2 mapped to -1, -1 mapped to 0, and so on. Is this a function or not a function? Yes, of course, it is a function because this is a one-to-one relation. All right? Any question? Now, let's have another one, which is by means of ordered pairs. All right. So we have here our set of ordered pairs. So where did I get this ordered pair? Okay. So if you're going to get back in our previous slide, right? So these are our ordered pairs. So x and y values are being joined together. So -2, -1, -1, 0, 0, 1, 1, 2, and 2, 3. So these are our set of ordered pairs, right? Therefore, our ordered pairs here is also a function. Okay? All right. So another one would be by means of a graph. So since we have already our ordered pairs in the previous slide, right? So we're going to plot those ordered pairs. So those are the points to be plotted in our Cartesian plane. So we have here our points. So -2, -1, -1, 0, 0, 1, 1, 2. Okay. And we're going to connect our points with the line. So this is the graph of our equation. Okay. So to determine whether the graph is a function, we're going to use the vertical line test. If the vertical lines will pass or intersect at exactly one point, the graph is a function. So this is our graph, right? This is our line, okay? So we're going to draw a vertical line. And if that vertical line passes at exactly one point or intersect at one point in our graph, therefore it is a function. Now, what if our graph look like this? So for example, we have our ordered pairs and our graph look like that. So for example, if we're going to draw a vertical line, so let's make our line red. Okay. So let's assume also that our line is straight. Okay. Our vertical line there is straight. Now, as you can see that our vertical line passes at this point and another one in this point. Okay. So if our vertical line passes at 2 points of our graph, therefore it is not considered a function. Okay. Any questions so far? None? Okay. So now let's proceed to the last one. So this time, we're going to use the equation. So that would be y is equal to x plus 1. So based from the ways of representing functions using the table, ordered pair, mapping, and graph, the equation y is equal to x plus 1 is considered to be a function. Of course, we already found out earlier that it is a function. So, for example, we don't know yet if it is a function or not. So how are we going to find out? So let's have our equation. So we're going to use f of x is equal to x plus 1. So we replace our y with our f of x, and that is equal to x plus 1. Okay. So say, for example, we input -2 into our x, and that would be f of -2 is equal to -2 plus 1. So we replace our x with -2, then plus 1. And that would be f of -2 is equal to -1. But our answer here is an integer, right? It is equal to -1. Therefore, it is a function. All right? Any questions so far? None. So check your progress. So again, this will be serving as your assignment for this lesson. Okay? So all you need to do is just follow what we have done earlier for you to answer these problems. Okay? So we have 3 slides for your assignment. But here on the second slide of your assignment, you have to graph your C. Okay? All right? Here, you're going to determine whether the following sets are relations or functions. Okay. I think that will be all for today. Thank you so much for listening and watching this video. Please like and share this video to your friends. And don't forget also to put your comments down on the comment section. So if you have questions regarding this topic, please feel free to write your comment below. All right? And please consider subscribing to this channel. You know, I will be very glad and excited to make more videos for you to help out with your math lessons. So again, this is your Sir O saying goodbye for now. And of course, keep safe and God bless everyone.